Okay, so first question, we struck you with a vector diagram. That's where a lot of students will, how to do. Then they'll spend a lot of time thinking, pondering, and end up wasting their time. So if you're not proficient in your vector diagram, skip. For paper 2, you can skip questions first. Handle those things that you're confident in. You get the marks ready, you feel more confident. Then after you're done, you come back to those questions that you're not good in. Don't spend a good 15 minutes just to think about how to do this when you don't even know how. Okay, but if you're good in this, you'll know that this is a young otter swimming in a river. When it is swimming in still water, it has a top speed of 2 meters per second. It is swimming in a straight river whose waters are flowing at a uniform speed of 4.5 meters per second. By drawing to scale, that means you need your vector diagram. A labeled vector diagram determine the otter's velocity if it swims at top speed directly across the river. So what is the motion of the otter? It will go this way, right? And it is 2.0 meters per second. Okay? Vector diagram applies here because there is a magnitude, there is direction. So it may not always be forces. Then on the other hand, we have this constant uniform river flowing from left to right with a magnitude of 4.5 meters per second. Then they want you to know to determine the otter's velocity if it swims at top speed directly across. That means they want you to know where he landed. His motion is this way. Okay? He's swimming directly across. Right? So if he swims from here and if the river is not flowing, where will he end up? He will end up here. But then because there is a river flowing, therefore he may end up somewhere here. Common sense, right? But what is the way to do it for physics? Tip to tail. Tip to tail, right? So the way to do it, later on I'll show you the actual answers, yeah? But now it is, okay? So if I look at the space here, I can say maybe 1 cm represents how much? 0.2 meter per second. From the paper, do we have 10 cm? Okay, so anyway, we will have 10 cm for this. Right, you draw a 10 cm line. Okay? Darren, why you look so short? Too long, huh? I don't want to use 0.4. Yeah, I use 0.4 lah. Okay, how about this? 2 cm, 1 cm will represent 0.4 meter per second. Therefore, this line that I drew for the otter's top speed will be 5 cm. And I must try to draw it. I must have my cross here. The cross will give me an orientation. It will give me an orientation. So now I will need to draw in from the start. If you do 0.5, right, then it will be how many cm? 9. Why 9? Huh?
If you use a scale of 0.5, 4.5 will be 9 cm.
Why 4.5? Oh, this one, this on top, is it? Oh, okay. I'm not done yet. Oh, then there'll be okay, good. Sorry, I didn't consider this. Maybe I should let 1 cm represent 0.5 meter per second. Because Ara pointed out 4.5 meter per second if I were to use my 1 cm to represent 0.4, later on I will have decimal points that my ruler cannot measure. Because my ruler can only measure up to 0.1 cm. So then I have to use 0.5 meter per second, and that means my 2 meter per second will then become 4 cm. Okay, 4 cm, yeah? So I draw from my center of the cross, and in my mind I visualize that it's going to look like that. It's going to look like that. So my cross, I don't start it at the center, I don't start it at the top. Because I already have a visual of how my vector diagram is going to look like. Because all I want is to make them into tip to tail. Yes? So this will be my 2 meter per second, and it is actually 4 cm. Yes, because I'm now using a scale of 1 cm to represent 0.5 meter per second. Then now I will draw in this. And I will draw it at the end of this part. And it will look like, this is 4.5 meter per second. It will be a length of 9 cm. Okay, so are they already arranged in tip to tail? Yes, right. The tip of this blue arrow is touching the tail of this red arrow. So this one is quite simple because there's a resultant force. Later on, I'll touch about no resultant force, but you need to take note. So then, where did I start from? I start off from here. This is the start, and I end here. So the resultant force will actually be from the start to the end. And you must draw it with a double arrow to show resultant force. Okay? Then, if I were to measure, and then I will apply it back to the scale, I will get a certain value. Okay, so this is just a rough guide. It's very difficult for me to draw actually on this. So can I show you the answer? Is this the same thing? Same. Is the river still going from left to right? Is the otter still going upwards? Same, right? Same, right? Is it arranged in tip to tail? So the value of this diagonal, which is the resultant velocity, will be the same as mine. Okay? So in fact, this one is quite simple. Yeah, if the question asks you to find resultant force, it's always simpler than when a body is in equilibrium and there's no resultant force. What if they didn't ask you to find resultant? They tell you it's in equilibrium. Yes. Yeah, I switch screen. Anyway, this answer, was it uploaded? No, I will upload the answers. Okay? You all have to try yourself. Vector diagram, you have to try yourself. So what if it is a case of no resultant force? How do I know that there's no resultant force? When they tell me that the object is stationary, in equilibrium, or balance. If they tell me these three things, then it is a case whereby there's no F net, no resultant force. Right? So example, it will then end up, your vector diagram will look something like that. Where is the start? Where is the end? Is it still arranged in tip to tail? It is still arranged in tip to tail. I never break any laws, right? It's still tip to tail. It's always to be in tip to tail. But now, where is the start? Where is the end? There isn't a start, there isn't an end. It's a never-ending cycle. Which means there is no result. Which means there's no resultant force. But if you look at this, is there a result? There is a result, therefore there's a resultant force. Alright? So for this, the way to do it is still always to make it into tip to tail. This one, can. Very classic one. Okay, okay. Yes. 23 to 25. Ah, 11.7 is too much already. If you use Pythagoras, you will have gotten 23 to 25. Pythagoras. Okay. Okay, you can use sine, which is actually this angle, right? Sine opposite, which is your 2 over hypotenuse. 9.9, ah. This is 2. This is 4.5. Okay. Why do you use 9? I use 2 meter per second and 4.5 meter per second. So you find this angle. Sine theta equals to opposite over 4.5. I'm finding this angle, right? Oh, yes. Tangent. That's why I'm not teaching math now. So tangent theta equals to 2 over 0.5. So if you do this, you should get between 23 to 25. Okay? All clear about how you get the angle, but you must measure lah. Okay, then Arya asked me for a typical question of no resultant force. You all have seen this before. This one? Have, What are the 3 forces that is acting on this pendulum box? Tension 1, tension 2, and the weight, right? So, some students, when they draw this vector diagram, they include the ceiling. Once you include the ceiling, your vector diagram is going to go wrong. Your vector diagram is going to be wrong. Okay? Let me ask you. A man pulls a box with a rope. He's exerting a force. Another man pulls a same box with a rope. Whose force is bigger? Whose force is bigger? First or the second? Whose force is bigger? I don't know. Because this is just the length of the rope. This is just the length of the rope. The length of the rope doesn't tell you how much is the pulling force. The length of the rope don't tell you how much is the pulling force. So, my point here is, I have a ceiling drawn here. I have 1 rope, I have 2 ropes. And if you were to just follow the length of the rope to say that that is a force, you are wrong. Because the length of the rope don't tell you what is the force. Correct? The weight of this microphone is like that. Does it change? Does it change the weight? Does it change the weight? No. So you cannot go and measure the length of the string and say, oh, this is going to be a certain force. No. You have to see from the diagram see from the question what forces they give you. Understand? Then there's one more question like that. A pole, okay, is being supported by 2 lengths of rope, right? What are the forces acting on this pole? Weight, tension force, tension force. Okay, then you have to make it into vector diagram. Which one? What is the force that is acting on this rod? Yeah, so imagine now you are being pulled down by this, right? So isn't it in this direction? So does that mean the give two of the like length and then the other one? Find the third one. Find the third one. What do you mean?
The example they give you like tension of 2 and then they ask you to find weight like that.
They will. They may. Okay. Okay, so if you need practice, I will find these two questions. Then I will print for you. Okay? Can So this is for a vector diagram. If you know how to do it, it comes out, it's an easy 4 marks. If not, you're not so clear about this, skip this question first. For this one, for any, it depends. It depends, It depends. Okay. This is the tension force. This tension force is acting on who? When I draw this arrow like that, and I tell you that this is a tension force, this tension force is acting on man, rope, or box. Man, rope, or box? On box. On box. On box. But what is the direction of the tension force that's being exerted by the box? Man pull box. You are the box. I pull you. What's the direction of the force that I'm exerting on you? Towards me, right? Towards me. Now, you are the box. You are still the box. I'm trying to pull you. What is the direction of the force that you are exerting on me? Towards you. Then, what is the direction of the force? What's the direction of the tension that's exerted on the rope? On the rope. Right? By both man and the box. Okay? So it depends on who is the object you are talking about. Right? Now, if I have a pendulum, who is the person that you want to talk about? The ceiling, the rope, or the box? Or the box? Who? Who is the subject? The box, the rope, or the ceiling? The box, The box, So I want to know the direction of the tension force on the box. What is the direction? Up, down? Up. Because without this upward tensional force, my box will drop. Correct? Correct? Imagine you are the box. How come you never drop down? Because there's a tension force. And this tension force is pulling you up. Can? Now I change, You are a helium balloon. What is the direction of the tension force acting on the helium balloon?
Downwards.
Downwards. Because your helium balloon, by right, you should float up. Why didn't you float up? Because there's a tension force acting through the rope, pulling you downwards. Okay? So it depends on who you are talking about. Which object are you interested in drawing all the forces acting on that object? Can? So this one is after you have calculated, after you have drawn the vector diagram, okay, see if you understood this. Actually, this question is somewhat similar to your vector diagram tutorial, the tortoise one. There's a tortoise swimming in a river. Okay, you can go back and revisit. If you have forgotten what I'm talking about, means you have not started revising. So the journey time, because the question says that river is 10 meters wide. That means from far bank to the near bank is 10 meters wide. So if there is no river flow, the river stationary, he will just take 5 seconds to travel from near bank to far bank. Correct? It will take 5 seconds. And during these 5 seconds, the river actually transports him from left to right with a speed of 4.5 meters per second. So in the end, he will end up 22.5 from his original intended outward position. So figure 2.1 shows an evacuated chamber. Do you all know what's an evacuated chamber? Vacuum, no air. That means no air resistance. A ball is launched horizontal from the wall and lands on the base. Okay, it lands on the base. So initial height of the ball from the base is 50 cm. Use this following equation to determine the time taken for the ball to reach the base. Have you all seen this equation before? S equals to half gt squared. Where did you see it? Yeah. So maybe it's a good time to go and revise now. S equals to ut plus half at squared. Right, this was one of the formulas that I showed you all. The other one is, okay, because last time we learned all the formulas, we didn't really do much. Now they give us this formula. Where is my ut? How come my ut is gone? Ut becomes 0, yes, but why is ut 0? Which one is 0, the t or the u? This becomes 0, right? Where did it go to? Where's the u, where's the t? T is, by right, this u multiplied by the time that it travels, it should have a certain value. So time continues one. Time will just continue, right, for this motion. So it means that the u is 0. But then the question says it was launched horizontally. That means if it's launched, there must be a initial speed, right? Your u cannot be 0, right? So the answer here, anyone knows why the ut becomes 0? Although the ball was launched horizontally.
Is it because the initial velocity is 0?
Why is the initial velocity 0?
Because before it was launched, it was 0.
Okay, then let me tell you, this question a bit unfair because this one deals with projectile. It was launched horizontally. So in the horizontal direction, u horizontal, it is not 0. Horizontally, because it was launched horizontally, right? The horizontal initial velocity, which is your UH, is not 0. Was there any initial velocity in the vertical direction? The UV is 0. The UV was 0. The question is asking you, determine the time taken for the ball to reach the baseline. Actually, they didn't expect you to think so much. They just asked you to substitute this formula. But in case some of you later know about this formula, then you ask, hey, where's the UT? Okay? And what is this G? It's actually gravitational acceleration. Right? So, never mind. We just use this. S equals to half gt squared. How do we find the time? You need to know the S. How do we know the S? 50 cm, right? Because it is vertically. Correct? In the end, where does it end up? At the bottom, right? The vertical displacement is 50 cm. But if you substitute 50, you are wrong.
It's 0.5.
It needs to be in 0.5 because you need to have it in meters. So equals to half. Your 10 is actually 10 meter per second square. That's why you have to substitute it as 0.5 meters. Then after that, you should get your T to be 0.316. Okay? Velocity of the craft directed away from Earth decreases from 5500 meter per second to 5454 in 2 minutes. The mass is this. Calculate the average force acting on the craft at this time. Okay? I'm just doing this on the fly. That means before that I didn't look at the answers of question. So I was actually, when I was underlining, I was a little bit panicking. They're asking me for the average force. Average force means there must be F net. Then F net means I must have MA. Then I was looking, I have my M, I have my V, my U and V. Then where's the time? Then I was looking around, the 2 minutes. That means in exam, you must underline all the numbers, which you all don't, which you all never do. Why? Just underline and annotate. It will help in your calculation. Calculation, I really have to leave it to y'all. Okay, y'all must do a lot of practice. The explanation, I let y'all read that thing. Okay, then we can do well. Right? But you must follow what I'm telling you. Underline the numbers. If it decreases, that means which one is the final velocity? 5454. Check that the units tally, minus 550. 2 minutes, do I need to do anything? Change to what? Because everything was in meter per second SI unit, so the time need to change from minutes to seconds. So I'll get a certain value. Let me check my answer. Negative 0.3833. Okay? Okay, please do the rest of the questions in here. And I'm hoping that some of you have already finished. So I'll give you the next step. Anyone absent today? I'll keep for him. Okay, you all can go for our next lesson. Thank you, class. Right. Do this, I can tell you didn't do, I'm just thinking of what to do with your for the next few lessons. Just do paper.
Because if you do the paper, then you may not finish the whole thing.
Like
Later on.
Huh?
If you go through the paper and don't finish the whole thing, then the answer will then we won't have consistency. So if you did the video, instead save maybe get consistency. Yeah.
But still need thank you. But still need to do something during lesson.
Yeah, that's true. You do paper.
Do paper during lesson.
Yeah, actually why not? Yeah. Do a paper, then you can go
Okay. I'll think of something. Yes, I know what to do.